Okay, let's if you watched my part one, I think, the prequel to this, if you will, where I talk about one-to-one functions, then you know a little bit about one-to-one functions already. I talked about how to be a one-to-one function, each element in the domain and each element of the range gets used exactly once. Now, if you remember back in my 2.2 videos for intermediate algebra, Math 1010, I mentioned that to be a function, it has to pass a vertical line test, okay? So, let's think about that and take that to the next, well, let's work with that idea first, okay? Vertical line test. So here I've got, all right, I got 1, 2, 3, 4, 5 graphs here. Are these graphs one-to-one functions, or not even a function? Let's actually answer the last question first. Are any of these guys not functions? Vertical line test. Let's make use of it. Boom, right there. It already flunked it right there. So that's not a function. So that guy's out. If it's not a function, then it's not even a one-to-one function, right? Anything else not a function? If you said no to that the second graph is also not a function, you are correct. It's going to fail all over the place there, huh? So the first two graphs aren't even functions, so I'm done talking about those two. Let's look at the last three. Are they one-to-one functions or just functions? Well, here's where the horizontal line test comes into play. Now these guys, hopefully you'll agree that they'll all pass the vertical line test, so they're all at least functions, okay? So I'm going to say function here, and here, and here. Now, of these three, which one do you think is not going to be a one-to-one function? If you're tucking the one right next to my ear, you're right, this guy. Okay, it's going to fail the horizontal line test in a whole bunch of places, so it's not one-to-one. So basically, the horizontal line test, what that is, it's pretty much the same thing as the vertical line test. If you can draw a horizontal line at any point on your graph, and that horizontal line only crosses the graph in one place, then you've got a one-to-one function. That works the same idea as the vertical line test for a regular function, right? To be a one-to-one function, all your domain values get used once, and to be a one-to-one function, all your range values get used once, right? Which makes sense for the horizontal line test. If it only crosses the graph once, that means your range only got used the one time, right? So, here we go. That works. And that works. So they're both going to be one-to-one functions. And that'll take care of that. I can learn how to spell one. There we go. Okay, which brings us to finding the inverse of a one-to-one function. So in the previous video, I talked a lot about one-to-one functions, and I talk about it for the first 4 minutes of this video. And I mentioned it briefly that in the last video, or maybe the beginning of this video, I can't remember which, to have an inverse, you have to have a one-to-one function, right? So let's look at this guy first of all. Is this going to be a one-to-one function? First, is it going to be a function? Let's look at the domains. 2, -1, 0, -7, check. It's a function. Now let's look to see if it's a one-to-one function. -4, 13, 0, -8. Check. It's a one-to-one function. So how do you find the inverse? Okay, this one's going to be really easy. To be a one-to-one function, now first of all, my labeling is going to be like this, okay? To have an inverse function, they write that with a little -1 in the exponent. That means you've got the inverse, okay? Which makes sense. The inverse of x would be 1 over x, right? You flip it over. And using this type of notation, after the -1, you flip it over. So yeah. Well, all you're doing or an inverse function, you're just swapping places with x and y. That's it. So our answer here is just -4, 2, comma, 13, -1, comma, 0, 0 doesn't change because they're both zeros, comma. What do you think the last one is? -8, -7?
You were good.
Yeah. Got it. I can finish my brace here. Yeah, that's it. So you may be asking, wow, is that it? Is that all there is to inverse functions? No, of course, it's always going to get harder, right? Stick around. We'll talk about that.